Well, hi. This is the video for the course project of Big Data Analytics. And the name of our course project is Auction Recommendation for Advertiser. I'm Chen, and my teammates are Qi Xu and Xiaowen Li. When we search online through a search engine like Google, we usually would receive recommendations for advertisement. But right now, let's think in another way. There is also a potential need of recommendation for advertisers, so we can help them make wise choice on what phrase they should bid on, and how much they should pay for this phrase. So this is the motivation why we do this project. But for data, we require data from Yahoo Labs, and this data is advertiser phrase bipartite graph, which contains advertiser IDs and all the phrases that they bid on. And there are more than 2 million edges, each represent the act of an advertiser bidding on a phrase. For the whole project, the system consists of 3 parts. The first is data pre-processing part, which was accomplished through Python, so that we could convert raw data into formatted data. And the second part is recommendation, which was realized through Mahout and Java, so that we could get the final recommendation result. And the third part is data visualization, which was realized through Django and D3, so that we could visualize the recommendations to make sure that everybody could understand and see it directly. And let's start with the second part of this system, the recommendation part. For recommendation, the similarity algorithm is essential. So after we did evaluations, we choose 2 similarity calculation methods here. The first is Tanimoto coefficient similarity. This method was based on the ratio of the 2 sets to the union of the 2 sets. And the second similarity algorithm we used here is Pearson correlation similarity, which the basic thought of this calculation method is the ratio of the covariance of 2 datasets to their standard deviations, which ranges from -1 to 1, and we also use weight here, which would push the similarity value closer to -1 or 1, so that we could get a larger neighborhood and more recommendations for advertisers. And for the recommendation mode, there are 2 basic modes we use here. The first is user-based recommendation. Just as its name indicates, this mode was to calculate how similar a user is to other users. And the item-based recommendation mode is to calculate similarity between the items. And for our project, we use the combination of the 2 recommendation mode and the two similarity calculation method. So in total we use the 3 recommenders to get the final results. The reason why we do this is because there is pros and cons for each of the recommendation mode and each of the similarity calculation method. To get a more valid recommendation, we just combine all the 5 methods results and form our final result here. And here I'm going to show you a little demo of how we did recommendation and how we did evaluation. So here, let's look at this recommendation running program. So for this recommendation here, we use user-based recommender, and the similarity calculation method here is Pearson correlation similarity. So let's run this program and see how it works. Well, as you can see, there has been some recommendations come out. The first column represents the ID of the advertisers, and the second column represents the ID of the phrases that was recommended for that particular advertiser. And the third column is a recommended value for the bidding actions. And as for the evaluation, um, the way we evaluation here is for the user-based recommender, and the similarity calculation method is also Pearson correlation similarity. And here we parse this data into two parts. The first is training part, which contains the 95% of the whole sets, and left the only 5% to evaluate this recommendation method. And let's run this to see how it works. I set the iteration for this evaluation for 10 times. So after 10 evaluations, to get the average, we would get better and more valid evaluation here. And it takes a little bit time to get the recommendation. Well, we can see right now we get the first recommendation. It is about 55. Well, for the evaluation, the lower the number is, the better the evaluation results. And that's pretty much about how we did recommendation and evaluation. So next, my teammates, she's going to tell you more about the data visualization.
Hello everyone, I'm Qi. I will talk about the data visualization part. In this project, we develop a website to show all the recommendation and the advertisers bidding record. These are the tools we use to build the website. We deploy it on an Apache server and use SQLite as database to restore all the information. And our web framework is the powerful Django with Python. Actually, this is quite a popular web engine. And the D3 is a JavaScript-based toolkit to visualize the data. Then I will show some demo of it. First, we run the server in the Ubuntu terminal. Okay, it's on. And go to the local host. This is the home page of our site. You can input a valid user ID with the corresponding password to log in our system. Let's say this one. After you log into the system, you will see the user's home page. The bar chart illustrates the user's previous bidding, and the recommendation as well. If you click one of the bar, you can see the detailed recommendation or the recording of on the phrases. The horizontal axis indicates the recommended price, and the vertical axis shows the phrases. And click the blank area to the last page. Of course, if you are interested in some specific phrases, you can search it. Let's say this one. This page is a phrases home page. If you search the phrase and it is in our database, the praise page will jump to here. You can see all the bidding record on this phrase here by clicking the bar as well. I think this is quite helpful. to the advertisers. After you finish viewing the recommendation or the record, you can log out to the home page. And for another user like this one, you can log in this as well. That's all of the recommendation part. Thanks for watching.
Since we talked about our motivation, introduced our system and data, described two similarity algorithms, as well as two kinds of recommendations, and provided a simple demonstration, now we are going to talk about our future work. We think about three possible main parts that may make sense in the future. The first is the real-time system, because it will cost a lot of time to add new advertisers or new phrases in our current system. And making recommendations for users in real time is also time consuming, especially for a system with large amount of users and phrases. So to implement a real-time system is a good way for future work. The second part is blind recommendation, because in our system, we cannot make recommendation for users who did not bid on anything before. So in the future, we hope to make blind recommendation for those users. And the third part is website improvement. In our website, just as illustrated, the advertisers can get first information and obtain the recommendation we provided. In the future, we hope to put more functions in our system, like we hope to add a priority for more than one recommendation and build a platform that advertisers are able to communicate with others. That's all about our project. Thank you for your kind attention.